Hi, so this is Sarah Schaefer, and I am retaking Quiz A. The first question says, how many significant figures are there in the following values? A is 3,200, but it has no decimal point. Therefore, it only has two significant figures. These zeros are not significant because they do nothing except for set the decimal point. But because there is not a decimal point, they are not significant. So A only has two significant figures. B is 3.20 times 10 to the third, so same as 3,200. But this number has three significant figures. This zero is significant because it is both to the right of the decimal point and it is to the right of a non-zero. So this zero is significant, so we have 1, 2, 3. 3 significant figures. C is 3,200, but with a decimal point and a zero behind it. So we have 1, 2, 3, 4, 5. So this has 5 significant figures. This zero is significant because it does not hold a decimal point. So therefore we count it. So those are the significant figures for question number 1. Question 2. Perform the following calculation to the correct number of significant figures. Don't forget to include units. So first, let's count the significant figures of each one. So first number, we have 1, 2, 3, 4, 5. So this is 5 significant figures. Once again, this 0 is significant because it is to the right of a decimal point and it is also to the right of the non-zeros. Yes. This one has only 2 significant figures, 8 and 4. While this 0 is to the right of the decimal point, it is not to the right of the non-zero, so therefore we don't count it as significant. So we only have 2 significant figures. And then these are all non-zero numbers, so this is 5 significant figures. So when I put this into my calculator, I get 0.678 grams over centimeters cubed. Of course, this was a much bigger number, but I'm going to kind of stop it after 3 because I'm only going to 2 significant figures. Also, too, we have the grams and the centimeters cubed. Grams do not cancel out because it's only a subtraction, not a division. So we keep the grams and then divide by centimeters cubed. So we keep all those units. Therefore, we're probably figuring out the density for something. So if I'm only doing 2 significant figures, then I want to take this and round, since it's an 8, I round the 7 up, and so I get 0.68 grams over centimeters cubed for that one. So this is the final answers with significant figures. Okay, question number 3. Dry ice is solid carbon dioxide, CO2. It undergoes a physical change, sublimation at room temperature. The density of dry ice is 1.56 grams over centimeters cubed at 22 degrees Celsius. In order to perform some chemistry demonstrations, I went to Winco and purchased 2.3 pounds of dry ice. What is the volume of this dry ice in units of cm of centimeters cubed at room temperature? Show your work. Report your answer to the correct number of significant figures and with the correct units. Okay, so looking at the question, we are given... Sorry about that. Looking at the question, we are given the density of dry ice. It doesn't really... I don't have to really consider the temperature for that. So I will use this. What we are given is 2.3 pounds of dry ice, and then you kindly gave us 1 pound equals 453.6 grams. So the first thing I'm going to do, and I want to find the volume of dry ice in centimeters cubed. So what I take is my given, which is 2.3 pounds of dry ice, which is essentially CO2. So then I'm going to convert this into grams. So I'm going to use this conversion factor that we're given here. So 1 pound is equal to 453.6 grams. So now I have grams at the top, which is good, and now I can use the density that we were given of dry ice. Okay. So, we're going to put grams on the bottom, so that cancels that out. So 1.56 grams over 1 centimeter cubed. Okay, so when I put this into my calculator, I am given 668.769 centimeters cubed. I forgot because so pounds cancel out, grams cancel out, and then I'm left with centimeters cubed, which is what the question asked of me. But then I need to account for significant figures. So when I look at the question, I see that this is my smallest number, so I only have 2 significant figures. So when I take this, I look at this one and this one, so then I use the third number to round. So my final answer is, so because it's 8, I'll round up, so it's 670 centimeters cubed. So if you buy 2.3 pounds of dry ice, you will have 670 cubic centimeters. Yeah. Okay, and then the last question. A student used a balance and graduated cylinder to collect the following data. So we have the mass of the sample. Then we have the volume of water, and then the volume of water and the sample. So we take these two numbers, do 21.5 milliliters minus 20.0 milliliters equals 1.5 milliliter. Okay. So the question says calculate the density of the sample. Show your work, report your answer to the correct number of significant figures with the correct units. Okay. So we know that density equals mass over volume. Because, yeah. And then if we plug in the numbers, so the mass of the sample is 10.23 grams, and the volume is 1.5 milliliters. Okay. When I plug this into my calculator, I am given 6.82 grams over milliliters. Okay. When I look at the numbers that I was given in then I find that significant figures are 3. The lowest number of significant figures is 3. So I can keep 1, 2, 3. So my final answer is 6.82 grams over milliliters, which is the correct units for density. However, if you wanted to, you could change milliliters to centimeters squared. It's the same thing, or cc. So this can be changed to either one of those. All right, and that is the retake for quiz A. Thank you for your time, and thank you for this opportunity. Have a good day.